Okay, let's dive in. We've got this really detailed guide here, focusing on the hardware domain for the CompTIA A+ Core 1 exam.
Yeah, it's pretty comprehensive. And honestly, it's useful even if you're not going for the cert, just understanding what's inside your computer.
Exactly. It's a great way to understand the nuts and bolts. So we're going to pull out the most interesting bits for you.
Think of it as the highlights reel for computer hardware essentials. No super dense tech speak, just the useful stuff.
Right. Our mission then is to cover the key things about cables, RAM, storage, motherboards, CPUs, power supplies,
Right.
even printers. Focus on the practical knowledge.
And maybe some of the surprising details that people often miss.
Okay, let's start with cables. They seem simple, but there's more to it. Did you know about plenum-rated cables?
Ah, yes. For running network cables through air circulation spaces, like ceilings. It's a fire safety thing. They don't give off toxic fumes.
Interesting. And then there's USB-C, one little port doing data, video, and power.
Super versatile.
Mhm.
And becoming the standard, which is nice. Key thing is just recognizing the main types.
Like RJ45 for Ethernet.
Your standard network plug. Then USB-A, the rectangular one we all know. USB-C, which is the oval reversible one.
HDMI for displays.
Right. And SATA, internally, for connecting your hard drives or SSDs.
Hmm.
Just knowing what they look like helps.
And speeds. USB speeds have jumped like crazy from
Yeah.
USB 2.0, was that 480 megabits?
Yeah, 480 megabits.
Yeah.
Then USB 3.0 brought a big leap, and it's only gotten faster. Using the right port and cable actually matters for transfer time.
Definitely. Okay, moving on to RAM, memory. It's not just about the gigabytes, is it?
Not at all. The type is critical. You got DDR3, DDR4, now DDR5. They have different speeds, use different amounts of power.
And they physically won't fit in the wrong slot. Right?
Exactly. Different notches, different pin counts. You can't mix them up. They're not interchangeable.
And sometimes you see RAM sold in pairs or sets of 4. That's for memory channels.
Correct. Dual channel, quad channel. It basically gives the CPU more paths to access the memory simultaneously. Boost performance.
But you need identical sticks.
Yeah, ideally identical modules installed in the right slots, as per the motherboard manual, to actually enable those extra channels.
So, key takeaway for upgrading. Match the DDR generation, DDR4, DDR5, whatever, and the form factor. Dim for desktops, so dim for laptops.
Check that manual, always. Okay, storage devices. This is a big one. The shift from HDDs to SSDs.
Huge difference. HDDs, the old spinning disks, give you lots of storage cheap, but they're slow and, well, mechanical.
Right, they have moving parts.
Yeah.
SSDs use flash memory, like a giant UST stick. Much faster, much more durable because there's nothing spinning.
And now there's M.2 and NVMe SSDs. Those are even faster.
Oh, yeah. They plug right into a special slot on the motherboard, bypassing the older SATA connection. The speed difference, especially for booting Windows or loading games, is really noticeable.
Wow, okay. What about RAID? That sounds complicated.
It can be. RAID stands for Redundant Array of Independent Disks, basically using multiple drives together.
For speed or safety?
Either, or both. RAID 0 stripes data across drives for speed, but if one drive fails, you lose everything. RAID 1 mirrors data onto 2 drives, so if one fails, you have a backup.
And there are others like RAID 5.
Yep, RAID 5 and RAID 10 offer combinations of speed and redundancy. It's clever, but setup and potential recovery need care.
Gotcha. Let's talk motherboards, the main hub.
The central nervous system, yeah. Different sizes. ATX is standard, micro ATX is smaller, ITX even smaller. That affects how many expansion cards or drives you can fit.
And they have all the connectors power, the PCIe slots for graphics cards.
Right, PCIe slots for add-on cards, SATA and M.2 for storage, USB headers for the front panel ports, CPU socket.
Yeah.
Understanding those is key for building or upgrading.
The CPU socket is crucial, right?
No.
Determines if you use Intel or AMD.
Absolutely. And even which generation of Intel or AMD processor fits. You can't just stick any CPU in any socket.
And the CPU itself, cores, clock speed. That's about processing power.
Pretty much. More cores and higher clock speeds generally mean better performance, especially for demanding tasks. Some CPUs also have basic graphics built in.
And don't forget the BIOS, or UEFI. That's the first thing that loads up.
Exactly. The firmware on the motherboard. It starts the system, lets you configure boot order, enable things like virtualization for running virtual machines.
Secure boot, TPM for security. That's all in the BIOS UEFI settings.
Correct. Okay, quick one.
Yeah.
Power supplies, the PSU. Often overlooked, but critical.
It powers everything, right? Converts AC from the wall to DC for the components.
Yep. Main thing is the wattage rating. need enough power for all your parts, especially if you have a beefy graphics card.
And modular ones are easier for cable management.
Much easier. You only plug in the cables you actually need. Helps airflow too.
Okay, last area. Printers and multifunction devices. Still relevant.
Surprisingly so, yeah. Knowing connection types USB, Ethernet, Wi-Fi, and how to install drivers and share them is useful.
And scanning functions on multifunction devices, scanning to email or a network folder.
Right. Laser and inkjet printers are the main types. Totally different tech. Laser uses toner powder and heat.
Inkjet sprays liquid ink, different consumables, different maintenance.
Exactly. Replacing toner, replacing ink cartridges, sometimes fusers on lasers, print heads on inkjets. Basic stuff can save a service call.
There are thermal and impact printers too, but less common for typical users.
Right, more for specific uses like receipts or multi-part forms.
Okay, so wrapping this up. For you, the learner, this hardware knowledge is really foundational. Helps you understand your devices, troubleshoot.
Or even plan an upgrade. Knowing these core concepts, how RAM works, why an NVMe SSD is faster, it's valuable stuff.
We've really just scratched the surface, of course. Each area goes deeper.
Absolutely. Which actually brings up a question for you listening. What part of all this hardware stuff sparked your curiosity the most? Anything you'd want to dig into further?
Yeah, think about some of those details, like the plenum cables or the different RAID levels. Sometimes the small details unlock a bigger understanding.
Hopefully this deep dive gave you a few aha moments and the clearer picture of the tech powering everything.